Hi everyone. In continuation of our lecture series on centroid, today we are going to discuss the procedure to find centroid of quarter circular area or the centroid of a quarter circle. So in this session we'll be finding out the location of centroid of a quarter circle. So let me show you a quarter circle here, friends. So this is a simple schematic of a quarter circle which is having its center at point O, let's say, and these are the reference axes. This is x-axis, friends, and this is y-axis, which is having origin at point O. Now we need to locate the centroid of this quarter circle. As you can see from the figure, friends, the centroid will be lying somewhere here. It will have x coordinate and y coordinate. So we are trying to find out the x coordinate and the y coordinate of centroid. If you see this diagram, friends, this will be the axis of symmetry. It means this particular axis divides the entire quarter circle into two equal parts. So I can say this is the axis of symmetry, friends. So from this simple geometrical understanding, we can make out that the x coordinate and the y coordinate of centroid is going to be equal. So we can say that the x bar equal to y bar. This is because the centroid is at the same distance from y-axis as well as from x-axis. Okay, so you can calculate any one, that is, you can either calculate x bar or y bar, and by using the same value you can also find out the another coordinate. So here I will be finding out the value of y coordinate of centroid, and then the same value will be of the x coordinate. So let's see how we can find the y coordinate of centroid of this quarter circle. Now I'll just remind you the procedure we have already discussed in the previous classes. So suppose we have got any area. So friends, we would like to find the centroid of this section or this area about this axis. Let me say this is the horizontal axis, friends. So this area of cross section or this area is going to have centroid at certain point. So let's say this point is centroid of the area. So we would like to find the y coordinate, that is, I'm going to call y bar of this centroid. So procedure is, we take a small area, that is infinitesimally small area, friends. We take a very small area, let's say dA, and its distance from the axis, let me call it as y. This is y, friends. So the centroid of this particular section or area about this axis is given by a simple expression, friends, which is y bar, that is y coordinate of centroid, is integration of y times dA, that is small area, infinitesimally small area, divided by integration of infinitesimally small area that we have considered. So the y coordinate of centroid is given by the dA times y, and then integrating it and dividing by integration of small area dA. Okay, so this is the expression of y coordinate of centroid. So now for this particular area, we'll have to consider an infinitesimally small area over here. So to make it simple, we are going to consider an infinitesimally small area in the form of a sector. You can see here, friends, this is a sector. So this sector has got very small angle d theta. So friends, this angle is theta, and while this angle of sector is going to be very small. Since the d theta is very small, the area of this sector is going to be infinitesimally small or very small, we can say. So the radius of this sector is r, and the length of arc of sector is ds. So ds is also going to be very small, friends, right? The area of this sector, which is having a very small angle d theta, is given as dA, because area will also be very small, friends. So that area will be dA. So let's assume that this dA is concentrated at this particular point. So this is basically the centroid of this sector we have considered. So instead of considering entire sector, we can consider a small point over here at which the area of sector is concentrated, and the distance of this point from the axis is y. So we got y, friends, we got dA here like this. So we needed y, that is location of small area from axis. So that is y we got over here, and the area dA also we got over here. Okay, so now with the help of this expression, we can easily find out the centroid of the quarter circle. So now let's proceed for that. So we wanted to find the y coordinate of centroid of this quarter circle, that is, we wanted to find out this distance. Okay, this distance. So it is given by the expression already we know, friends. So it is given by y bar equal to integration of y dA, so this y into this dA, and then integration of that dividing by integration of this area, that is integration of small area. So like this we are going to consider the sectors throughout the quarter circle. Okay, now please remember, this integration of small area will give you the total area of quarter circle. So the total area of quarter circle will be simply pi. The radius of quarter circle is r, so pi r square by 4. That's very simple. Okay, so from here you can make out that the integration of small areas throughout the quarter circle is the total area of quarter circle, which is pi r square by 4. So this expression will get simplified, friends. So here you'll be getting y bar as integration of y dA divided by pi r square by 4. Now the next point is we need to find out the expression of dA, the value of dA, and we also need to find the value of y. So let's see this particular diagram of the sector. Since this angle is d theta, friends, so this ds can be found out by simple geometry as radius times d theta, because the radius of this sector is, so since the radius of this sector is r and the angle of sector over here is d theta, so this length of this arc is given as r d theta. That is very simple. If you observe this sector carefully, this ds is approximately appearing as straight line, so we can approximate this sector as a triangle. So when you approximate this sector as a triangle, friends, it is looking like this, friends. So here we got O, and this length is ds, and this height we can say approximately radius, and here is the centroid. The area is sitting at this particular point. So we know that for a triangle, the distance of centroid from tip is going to be 2h by 3. Okay, so h means here h is basically r, friends. The height of this is taken as r. So the distance from tip to the centroid, location of centroid where area dA is sitting, friends, over here. So this distance is 2h by 3, and from here to here base, the distance is h by 3. This distance is h by 3, friends. So from simple geometry we are able to locate this distance, that is distance of this centroid of triangle to tip. So this distance is going to be from tip to, this is going to 2, h is r over here, so 2r by 3, that we got, friends. Okay, so now we have got the distance of this point to this point, 2r by 3. Now this is approximately like a triangle, so you can see here, friends, it appears like a triangle this way. So here at this point dA is there, friends. This we got as 2r by 3. This angle is theta, you can see from here. So you can see this triangle, friends. So if you see this particular triangle I have shown here, so this length from O to dA, this length is 2r by 3. So I can find out the value of y, this value, by simple trigonometric ratio, friends. This is going to be 2r by 3 sine theta. Since this angle is theta, it is going to be 2r by 3 this length sine theta. Okay, so we got the value of y as 2r by 3 sine theta. The next part I need is this dA. dA means the area of this particular sector. So the area of this particular sector can be approximated as a triangle, area of triangle, friends. So if you see here, I can say the area of triangle or sector for that matter is 1 upon 2 times base. Base is ds, friend. So ds is r d theta. So 1 upon 2 base times height is again r, friends. So you'll be getting dA as half r square d theta. Okay, so we got area dA as half r square d theta here. Very simple understanding. And we got value of y. The value of y is 2r by 3 sine theta. This is the value of y, friends. Okay, so this was the value of y. So y is 2r by 3 sine theta, and value of dA, the area, small area, will be half r square d theta. So having obtained the value of y and dA, let us substitute them into the expression. So let me call this as equation 1. So if you substitute in the equation 1, so you'll be getting y bar, that is y coordinate of centroid, as integration. So y is 2r by 3 sine theta. This is the value of y, friends, and the value of dA is half r square d theta, and this is whole divided by 1 by 4 pi r square. Now if you see here, this r is constant because throughout the quarter circle this sector will have same radius. Okay, so throughout this whole quarter circle this sector is going to have same radius, that is r. So this r square is constant, so r is constant, so I can cancel constant term from numerator and denominator, friends. So if you see here, I can cancel out the r square from numerator and the r square from denominator, friends. Okay, And here if you see, here 1 by 2 we have, and here we have 2, that also get cancelled out. So in the next part I can take constant outside. So in the numerator we have r by 3, in the denominator we have 1 by 4, so it is going to be 4r by 3. So 4r by 3 will come outside, and now we'll have integration of sine theta times d theta. Now if you see here friends, this integration has theta as variable. Theta is a variable for this integration. So I'm going to cover entire quarter circle starting from this particular line. Okay, so at this particular line, when you sector that over here, theta is going to be 0, and when it goes to this particular point, theta is going to be 90 degrees or pi by 2 radians. Okay, so I'm going to put that limit. So theta will be starting from 0 to up to theta will be going up to pi by 2. So we got friends 4r by 3 pi integration from 0 to pi by 2 sine theta d theta. Now I'll simplify it further. So integration of sine theta is minus cos theta. So I'll write down that also. Outside I'll be writing minus, and this is going to be cos theta, and the limit is here friends, limit is 0 to pi by 2. So when you substitute the limit, you'll be getting minus 4r by 3 pi as it is. Now cos pi by 2 is 0, cos pi by 2 minus cos 0 friends, lower limit is 0. So cos pi by 2, because upper limit is pi by 2 and lower limit is cos 0. Now cos pi by 2 is 0 and cos 0 is 1, so it is going to be minus 1. So if you simplify this, it is going to be minus 4r by 3 pi into minus 1, that is 4r by 3 pi. 4r by 3 pi. So friends, we got the y coordinate of centroid of a quarter circle as 4r by 3 pi. Okay, since x coordinate and y coordinate of centroid are equal, so we can say that friends, x bar is same as y bar, and that is same as 4r by 3 pi. 4r by 3 pi. Therefore, by using a simple procedure how we have followed over here, we can easily find out the x and y coordinate of centroid of a quarter circle or a quarter circular area. Thank you very much.